Hello everyone, this is the first lesson recording for IM2, April 19th, 2021. We started with quiz number 4 on polygon, angles, areas, and perimeters. So if you missed it for whatever the reason, please contact me ASAP to make up the quiz. What are we doing today? We are going to be continuing with area and perimeter of similar polygons and then moving on to circles. So something that we did not get to do, this is exploration on similar figures, area of similar figures and perimeter. So you are going to make a copy of this and the link is going to be in the chat. And when you go to the link, it's going to ask you to create a copy of these slides. That's going to look like this. Okay, so how do you do this? Well, you have the sample, you have a sample banner here that has the height of 1 foot, and the actual size that you are going to create is 3 feet. So the question is, how many times bigger is the area compared to sample size to the actual size, and how many times bigger is the perimeter? Okay, so to do that, we're going to first consider the area. Well, these are all the samples, right? And this is the actual, and this has the height of 1 foot. This has the height of 3 feet. So you're being asked, how many of these does it fit into the actual? How many of the samples? Because that's going to be the area, isn't it? Okay, so how many of the actual sample area is going to fit into the actual banner? So here we go. So that's like I can fit 1 here. Okay, and then I can fit maybe upside down one right here, so that I can fit 2 more of those. So you're trying to see how many of the sample banners can I fit to fill the whole actual. And it turns out you should be able to fit exactly 9 of them. Okay, so you should be able to fit 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. What does that mean? That means the area, the proportion of the area, the sample area to the actual area is 1 to 9. Okay, what about perimeter? You can do the same thing. For the perimeter, these are the length of the sample, and how many of this length can I fit in? So this is 1, 2, and 3. And I can do the same thing with the right side length. And that you should be able to fit 3 of them, because the scale factor was 1 to 3, wasn't it? So this is just a way for you to physically convince yourself that this is true. The scale factor, whatever the scale factor is, the area will increase by scale factor squared, while as the perimeter will increase by when the linear scale factor is 3, any length ratio, so perimeter is going to be increasing by a factor of 3, and the area will increase by not 3, but it's going to be 3 squared, because you're multiplying 2 different lengths to get the area. So it's going to be 3 squared, which is 9, and this is true for any shape. So now you're going to go on to decimals and card number 1 to 7. Card number 1 to 7 will look like this. Card number 1, rectangle B is the enlargement of rectangle A. Okay, so this smaller rectangle is being enlarged to the larger one. What is the linear scale factor? What am I multiplying to get from the original to the final? Okay, so what is the number that I'm multiplying to get there? It is 25 divided by 10. Okay, so it is like going from, this length is going from 10 to 25. So you divide the final, which is 25, divide by 10, which is can be simplified as 5/2 or 2.5. Card number 2. This time, what is the rectangle's area's perimeter? Okay, so we can calculate that. Okay, so what's 6 plus 10? This is 6 and 10. This is also going to be 6 and 10. So 16 plus 16 is going to be 32. Okay, what is the rectangle B's perimeter? Well, if I know this is multiplying by 10, or 2.5, what is this length going to be? This corresponding set length here. This length is going to be this, I multiply by 2.5. So for this length, I need to multiply by 2.5 as well. So 6 times 2.5 is going to be 15. So since I know this is 15, 25, I know this length is going to be 15 also. This length is going to be 25. So that's going to be 40. Double that is going to be 80. And how many times bigger is B's perimeter compared to the original? That is again final divided by original, which is 2.5. It should be the same scale factor. Card number 3. What is the rectangle A's area? What about the area? Areas is going to be length times height. So 6 times 10 is 60. What about area B? Rectangle B. 15 times 25. Using the calculator, well, I can get the decimals to do that for me. So 15 times 25. Oops. 15 times 25 is going to be 375. And how many times bigger is B's area? So that the ratio is going to be 375 divided by 60, and that should be 2.5 all squared, which is 6.25. Alright, when the linear scale factor is 2.5, any side length would also be 2.5 times longer. So the perimeter is also 2.5 times longer, and therefore, and while the area is 2.5 squared times bigger, which is 6.25 times bigger. And that's what we've discovered from the card number 1 to 3. Now we have some weird shaped polygon. Let's enlarge the figure so that the enlargement area is 1600 centimeters squared. How many times larger is the enlargement area? Okay, so this is the original. The enlarged is 1600 centimeters squared. So what is the ratio between the enlarged to the original? That's going to be 1600 divided by 100, and that is going to be 16. Okay, so the area increased by 16, factor of 16. How many times longer do you expect the enlargement perimeter is? Okay, so if the area increased by a factor of 16, what do you think was the linear scale factor? Something squared is equal to 16. What's that x value? Okay, it has to be 4, because 4 squared is 16. So I expect the linear scale factor to be 4, so that the perimeter is going to be enlarged by the factor of 4. What is the perimeter of the enlarged polygon then? Okay, so now I know that the original perimeter Okay, we can figure out the original. What is the original perimeter? That's 4 plus 8, that's 12. 12 plus 4 is 16, plus 5 is 21, 31, and 44. So the original is going to be 44 centimeters, and we have the linear scale factor of 4. So that's going to be 44 times 4. So I expect the enlarged figures perimeter to be 176 centimeters. Okay, now we have a trapezoid. Okay, trapezoid B is a reduction from trapezoid A. Okay, so they went from, this is the original, and went to reducing it to trapezoid B. What is the height of trapezoid B? So we're told that, well, we know that all the corresponding scale factor has to be the same. So what did I multiply from 40 to get to 5? Well, it's like dividing by 8, or what is that in terms of multiplication? It's like multiplying by 1/8. Okay, so dividing by 8 is same as multiplying by 1/8. Okay, so the scale factor is 1/8. So then what is this? If I say this is going to be the x, what am I multiplying to go from 10 to this height? I am multiplying by 1/8. So it's going to be 10 divided by 8, or 10 times multiplied by 1/8. So that's going to be 10 divided by 8, which is 1.25. And explain my thinking. I know that the linear scale factor from the original to the reduced image is 1/8. So I multiply 10 by 1/8, and that's what I would get. Okay, trapezoid B has the area of 30 centimeters. This one has area of 30 centimeters. What is the area of trapezoid A? Now, I multiply by, scale factor was 1/8. So scale factor was 1/8. That means the scale factor was 1/8. So that you would expect the area to be reduced by, area scale factor is going to be 1. So for the area, it's going to be multiplying by 1/8 squared, so that's going to be 164. 8 squared is 64. So I multiplied some number. So this is my area. If I call that the area x, when I multiply x by 1/64, I got 30. So what was my original area? It's going to be 30 times 64, and that's going to be 1920. So 1920 centimeters squared is my area. So let me write that. 1920 centimeters squared, and I know that the area scale factor, or area, decreased by 1/64. So to go backwards, I need to multiply 64 by 30, and that's what I get. And that's it for similar polygon area and perimeter. We're going to continue on the next recording with circles.